All right, today we're going to finish off chapter 12 by looking at one more specific type of sequence, and this one's going to be called a recursive sequence. And this one's going to be quite a bit different than our previous types of sequences because recursive sequences are defined by a rule which expresses each term by the previous terms. All right? And so with all of our other sequences, our domain values, unless you've been told otherwise, have started at 1, then go 2, 3, 4 consecutive integers. But with recursive sequences, our domain values are always the previous terms. So we're not going to go with consecutive integers. We're just going to go with whatever previous terms were given to us. So it's a lot different, quite a bit of a change from all of our other sequence problems. Now, one thing that messes up students all the time is just the notation. So our first example here, a sub n is equal to 3 times a sub n minus 1 plus 5. And the thing you really have to notice is that we start off with a sub n, which I hope you're used to by now, but the right-hand side of the equation is defined in terms of a sub n minus 1. So whatever value n is, n minus 1, of course, is going to be one smaller than that. So in our example here, I tell you what a1 is, and then if you were to go ahead and work at finding a sub 2 then is going to be 3 times a sub 1 plus 5. Please notice that the subscript on the second a is one smaller than the first a. But the idea is, hey, I tell you what a sub 1 is. I tell you above that a sub 1 is 4. So now when you do the math, 3 times 4, 12, plus 5 is 17. But what's a sub 3 then going to be? Well, that will then be 3 times a sub 2, the previous term, plus 5. But now what's the previous term? The previous term, a sub 2, is 17. So now my third term is going to be 3 times 17 plus 5. 3 times 17 is 51, plus 5 is 56. What's the fourth term going to be? 3 times a sub 3 plus 5. But our previous term is 56, so it's going to be 3 times 56 plus 5. Let's see if I can do that one in my head. So that's 168, so 173. And what would the fifth term be? Well, the fifth term then would be 3 times a sub 4 plus 5. But we know what the fourth term is because we just figured it out. So that's going to be 3 times 173 plus 5. And I better not try that one in my head. I'll get in trouble. 3 times 173 plus 5 is 524. And so if I were to ask you to find the first 5 terms in this recursive sequence, they would then be 4, 17, 56, 173, and 524. Please notice we're not putting in n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. To get to each term in the sequence, we're using what the previous term is. Okay? Now because of that, we always have to be given the very first term, at least the first term. We always have to be given the first value because we don't know automatically that we're starting at n equals 1. We can be told to start anywhere. Okay, so let's try a couple more examples. How about this one? Here I'm asking you for the first 4 terms of this recursive sequence. And let me see if I still have red. Yeah, so please notice that the n value on the left-hand side and the n value on the right-hand side, one different, n and n minus 1. So if I tell you that the first term is 3, then the second term is going to be negative 2 times a sub 1 squared plus 4. But since you know what a sub 1 is, you can replace a sub 1 with that number. Please notice I'm not putting in 1 or 2. I'm putting in the previous term. And when you guys do the arithmetic, 3 squared is 9, times negative 2 is negative 18, plus 4 is negative 14. Now to get to the third term, what we're going to do is take negative 2 times a sub 2 squared plus 4. But we now know what a sub 2 is because we just figured it out. A sub 2 is negative 14. And so a sub 3 then is going to be negative 2 times negative 14 squared plus 4. And if I'm punching okay, I hope I did, feel free to double check me there. I get negative 388. And if I'm going to get the fourth term, that's going to be then negative 2 times a sub 3 squared plus 4. But we now know what the third term is, so this is going to be negative 2 times negative 388 squared plus 4. And again, let me give that a try on my calculator. Negative 2 times negative 388 squared plus 4. Let me see. And I got negative 301,084. And we have the first 4. It's kind of hard to circle them up, but we've got the first 4. The first one was given to us. You'll see that in your assignment. The first one, at least, always has to be given to us. And then we can get the next ones. Always using the previous terms to get the next term. So the fifth term, if I were to go one more, would require me to use the fourth term. The sixth would require me to use the fifth, and so on. And because of that, very rarely can we ever jump to some term down the line. Very rarely can we ever jump directly to the 20th term or the 15th term or the 35th term. It's very difficult to ever jump down a recursive sequence. Okay? Now the next one might look familiar to some of you. Okay, I know the equation doesn't, but when I start writing down the terms, maybe they will. Okay, and what this one says is a sub n is equal to a sub n minus 1 plus a sub n minus 2. So this one's even more complicated. For every term in line, we have to take the previous term and add the term previous to that. And because of that, I have to start you off not at one number, but two numbers. So these two folks have to be given to you. And then the third term would then be defined to be the second term plus the first term. But the second term is 1, and the first term is 1, so 1 plus 1 is 2. The fourth term would then be defined to be the third term plus the second term, so that would be 2 plus 1, which is 3. The fifth term would then be defined to be the fourth term plus the third term, so that would be 3 plus 2, or 5. The sixth term would be defined to be the fifth term plus the fourth term, so that'd be 5 plus 3, or 8. And I haven't done this with any of the others, but this time I'm going to list them out with commas. So if I start with a 1 and a 1, then I'd have a 2, a 3, a 5, and an 8. And without listing any more A's down, I'm just going to ask you to go a few more terms. And what I'm just having you do here is to get to the next term, you add the previous 2. So the next term in line is just going to be the sum of the previous 2. So 5 plus 8 is 13. The next term, add the previous 2. 8 plus 13 is 21. 13 plus 21 is 34. 21 and 34 is 55. And of course, we could keep that going as long as you want. This is a really special sequence. It has a special name in math and botany and biology as well. It's called the Fibonacci sequence. And this is a sequence we'll talk more about in the future when you come back in pre-calc. It has a lot of neat applications in all kinds of areas of science. Believe it or not, this sequence of numbers comes up a lot. I'll show you examples of where this comes up in botany and where it comes up in biology. Okay? And then there's also going to be some combination problems. And by combination, I mean part of the problem is going to be recursive, and the other part is we're just sticking in a value for n. So here's an example, and I'm starting off at a sub 1 is equal to 3, and then asking you to go to a sub 2. Now what this is going to be equal to then is 2 times a sub 1, but here on the end is just a plain old n. So what I need to do is replace the n with the term number, which in this case is 2. Okay? And because we know what the first term is, what we'd end up with then is 2 times 3 plus 2, which gets us to 8. And then the third term would be 2 times the previous term plus the value for n, but this time the value for n is 3, and the previous term is 8, so I end up with 2 times 8 plus 3, which is 19. The fourth term would then be 2 times the third term plus the value for n, which is 4, but then the previous term is 19, so 2 times 19 plus 3 is 41. And let's do one more here. The fifth term would then be 2 times the fourth term plus the value for n, and the previous term is 41. I guess I don't need parentheses there, sorry about that. So the previous term is 41, so 2 times 41 plus 3, let's see, that'd be 2 plus 3, so that would be 85. And so I've been able to list out the first 5 terms in that recursive combo sequence that we have. Again, the first term is given to us, and then we're able to find as many terms as we want in a row. Okay? And then finally, there's one other way in which these problems could be written, and they could also be written as just plain old functions like f of x equals 4x minus 3. And if we give you a starting value like 2, if we give you a starting value of 2, then what we would ask you to do is find the second value by taking the function and putting in the first value. So take the function and replace x with 2. So that'd be 4 times 2 minus 3, so 8 minus 3 is 5. Then to find the third term, take f of the previous term, so the previous term is 5, which makes it 4 times 5 minus 3, so that would be 17. If we wanted to find the fourth term, we just take the function evaluated at the previous term, so 17. So it'd be 4 times 17 minus 3, so let's see, what is that? 68 minus 3, so 65. And just for fun, let's get one more. So we just replace x with 65. So we'll take f of 65, which is 4 times 65 minus 3. Let's see, 240, 260 minus 3, so 257. And when we use just a basic function and we repeat this process using the previous term, we put in the 2, then we put in the 5, then we put in the 17, then we put in the 65. We give this a special name in computer science, and this is called an iteration. It's called an iteration. All right? It means the same thing as recursive sequence, but just a little bit different language for doing exactly the same thing. Okay? Alrighty. So, the fifth section here, this recursive sequences are relatively easy. That's all there really is to them for now. So please go ahead and stop this video and go ahead and take a look at the problems there in section 12.5. Like always, let me know if you have any worries or issues on this one. All right, so I hope everybody's doing okay, and we'll talk to you soon. Bye.